Hello, this is Melissa,
And Casey.
and here's our submission for Project 3. So, first here we have our grading variables. AT is the total area of both the square and the triangle. AS is the area of the square, and A is the total area of the triangle. And they're all in meters squared because it's area. And then we have the side length of the triangle, which is S, and then the side length of the square, which is X. So down here we created our functions, and the area of the square is side length squared, and each side length is equal to 10, since that's the total area or total length of the starting perimeter minus 3 side lengths of the triangle divided by 4. So there's 4 side lengths of the square, and that's just 1 side length. And so that is where we plug this in squared for our total area function. And then for the area of the triangle, we used 1/2 of base times height, except to find the height of it, we did the function side length times sine of the angle, and that gives us our height times 1/2 times the side length gives us the total area in meters squared, and then add those two together gives you your total area function. And then here we found the derivative, which is here. And then to find the critical value, we set the derivative equal to 0, and our critical value is 1.9875 meters, when that's the side length of the triangle at the critical value.
Alright, next we did the first derivative test. So I went ahead and plugged in the value into the original function at one full space in either direction, and found that they were occupying the same height, meaning that they would have had to have been coming towards it at opposite slopes. And then to further verify, we have the first derivative test here. Once again, plugging in these two values, 1 unit to either side of the critical value into the derivative function, which once again found pretty much the same height, or one was negative and one was positive at those points. And then here we have our found values, one set calculated using the previous math, and then another set calculated using a spreadsheet I'd come up with. So there are 6 columns. The first one calculates the side length of the triangle, starting with how much percentage of or increasing by a percentage of the total perimeter it can take up. Using that, I was able to set it up to use side length as a function of the side length of the square as a function of the side length of a triangle, and then using these values to come up with the area for a square and for the triangle, as well as the total. And then in this 5th column allows using conditional formatting, I was able to have it highlight the lowest 1% of all data, which led to us finding, using the spreadsheet, a minimum value of 2.7185.
Which is not exactly what we got for other calculations, but it's pretty close. And having a spreadsheet show us very similar results was nice. We're engineering majors, so we like to use Excel a lot. And I'm pretty sure the area, or I guess on the Excel sheet, it's all marked as feet, but it should be marked as meters. That's our bad.
Yeah, I did that a little bit too early in the morning.
But yeah, here's our final answers, and hope we explained everything properly.